Facebook was rapidly outgrowing its infrastructure in 2009. Classic data center design was not up to the task of the rapid influx of new users and data, photos and streaming video, hitting Facebook's servers. A small team of engineers spent the next 2 years designing a data center from the ground up to be cheaper, more energy efficient, and more ergonomic for the engineers who worked within. That data center design was open sourced in 2011. Intel, Rackspace, and Goldman Sachs were the first 3 large organizations to join Facebook in the Open Compute Project, an effort to bring the benefits of open source collaboration to data centers. Steve Helvie works on the Open Compute Project, and he joins the show today to describe how the project has evolved in the last 6 years, and how it has affected data center design and the implications for the future. This is a pretty big and important project that is probably out of the purview of most software engineers, but it certainly has implications for software engineers, so I found this episode to be really intriguing. The process of troubleshooting bugs can be tedious and inefficient for developers, especially as they push more and more code to production. The unlucky developer assigned to bug duty may get bombarded with error alerts and spend hours figuring out which errors to address first. They might have to deal with logs to piece together what happened, or even spend time reaching out to other engineers on their team for help. Bugsnag improves the task of troubleshooting errors by making it more enjoyable and less time-consuming. For example, when an error occurs, your team can get notified via Slack, see the diagnostic information on the error, and identify the developer who committed the code. Bugsnag's integration with Jira and other collaboration tools makes it easy to assign and track bugs as they are fixed. We have a special offer for Software Engineering Daily listeners. Try all features free for 60 days at bugsnag.com/sedaily. Development teams can now iterate faster and improve software quality. To get started, go to www.bugsnag.com/sedaily. Get up and running in 3 minutes. Airbnb, Lyft, and Shopify all use Bugsnag to monitor application errors. Try all features free for 60 days at bugsnag.com/sedaily. Thank you, Bugsnag, for being a sponsor of Software Engineering Daily. It's much appreciated. Steve Helvie is the VP of Channel on the Open Compute Project. Steve, welcome to Software Engineering Daily.
Thanks, Jeff.
So today we're talking about the Open Compute Project, and this is essentially open sourcing what goes on in a data center. It was started by Facebook, and we'll go into detail about some of the history around this topic. But since this is a show for software engineers, let's first level set. Why should software engineers care what's going on inside of a data center?
Well, Jeff, I'd say that, coming from a software background myself, business application space, or even the OpenStack world, I never really paid that much attention to what was going on inside the data center as well. So when I moved over to the Open Compute Project, one of the things that I found interesting is how important the underlying infrastructure is when it comes to delivering your application. So as companies and as software engineers are out there developing new applications, it's really important for them to understand, does the data center and does the infrastructure team and the hardware infrastructure engineering team have a good sense of what it's going to take to run that application? And you're going to see in some organizations, those two organizations really combine, the hardware engineering team and the software guys, specifically at Facebook, the way that they design applications to run on specific hardware only in order to fit their massive scale.
Mm-hmm. Explain what the Open Compute Project is.
As you mentioned at the top, it was started in 2011 by Facebook with the essential premise that Facebook was out there growing at massive scale, and instead of working with the traditional OEMs such as an HP, Dell, or an IBM, they started to make their own hardware. And this is very typical for large hyperscale companies, the Microsofts, Google, Amazons of the world, they'll go straight to the manufacturer and say, this is exactly what we need to run our applications. So they did that, but on the backside of that, they took their community aspect of it and said, look, we have probably a couple hundred engineers maximum here on the hardware side. What if we open sourced all of our server designs, our storage designs, our rack designs, and even our data center designs to the broader community, get that community aspect going, and then we have a pace of engineering that happens. Having 4,000 engineers work on something is a lot better than a couple hundred. So that was the idea. Other views may say, yeah, look, Facebook, if you open source this, higher volumes is going to lower the cost to you and to the other hyperscalers. That certainly is a trickle-down effect ultimately, but in general, openness benefits everyone.
When does it make strategic sense for a company to open source its hardware?
If I'm a company and I'm looking at open sourcing a particular design, there might be a couple reasons I'm doing that. One is for new market entry. If you'll look at some of the latest numbers coming out from Gartner and IDC, the move toward openness is becoming more and more important. You have people, if you're running OpenStack, a lot of times it's inherently inevitable that the underlying infrastructure is going to become open in that way as well. These companies, the larger OEMs and ODMs, original design manufacturers, are looking for new market entry. And a lot of companies are interested in these new designs to run newer applications. So they're no longer running the proprietary software that you may be used to. They're now running Hadoop clusters, Ceph, etc. And this all can be run on new open source hardware, disaggregating the hardware and the software. So running everything via software, so it doesn't matter if the underlying hardware fails. So there's a massive revenue opportunity. And of course, I would say that there's a bit of move toward the open source in general. So a lot of these hyperscalers, the Microsofts of the world, Facebooks, Amazons, are pushing these guys to that market. So they're being pulled. And then, of course, there's the push for the additional revenue opportunity.
Mm-hmm. Why don't you tell us, what is life like for people inside of a data center? I think that's a very opaque role for a lot of people in software.
Well, the role inside of a data center varies dramatically. It could be as confining as the back room of a colo facility in Hong Kong. It could be, in the past, it's been these very small rooms with maybe even less than 50 racks. Some of the larger data centers now, thousands and thousands of racks in brand new free air cooling facilities. The day-to-day life of a technician can vary quite dramatically. I can share with you a bit about the Facebook experience. In a normal data center, non-Facebook or non-open compute, the number of technicians to server ratio is around 1 to 2,000 to 2,500 servers that technician would then monitor and care about. In the Facebook world, it's 1 for every 20,000. So as you can tell, they've really done an enormous amount of automation. If you walk through the floor of a data center at Facebook, there's hardly anybody around. There may be 1 or 2 guys just running the floor, repairing a few things here and there, but it's becoming quite automated with the new scale.
So how do data centers get designed? Or I guess maybe you could talk about in the past and maybe what Facebook did differently or what Open Compute Project data centers do differently.
Sure. In the previous world, the standard way to look at a data center is you would have raised floors, so for the air cooling underneath. You would have these large chillers, large air conditioners. The whole idea was that if I'm going to have all of these servers in a giant room, I'm going to make it as cold as possible so that we can run all of these guys without creating an enormous amount of ambient heat. What Facebook did is they realized that, look, instead of air cooling or instead of refrigerating the entire place, let's just contain it. So let's do hot aisle containment. So now, as you can imagine, you have aisles. So think of it as a grocery store. You have shopping aisles. One aisle is going to be hot, and that's the 2 servers back to back. and then you're going to have cold aisles. And so they use free air cooling. So they'll pump in air from the top using fans. Through drafting and through induction, they'll move it down through the servers. And these servers now can run at a much higher ambient temperature, up to 40 degrees Celsius. And in the wintertime, they'll add humidity to the air to warm it up. And then in the summertime, they'll remove that humidity through some dehumidifying to cool it back down. But what's important is that the Facebook data center does not use any giant UPS systems. It does not use any giant chillers. For a more simple way of measuring the effectiveness of an open compute data center is the measurement of PUE, which is the power usage effectiveness. It's an industry term, it's an industry standard. What it means is that for every unit of energy that I'm putting into that data center, how much of that unit of energy is going to the actual IT equipment as opposed to air conditioning, building maintenance, or opening and closing the doors, etc. So the Facebook data centers will run at a 1.03, 1.04. The normal data centers are up around the 1.2. So they run at an enormous amount of much higher efficiency than normal.
What kinds of issues can arise in a data center that is not properly designed?
Several. One is latency. Depending on how well you've architected your networking capabilities, there's certainly an enormous amount of efficiency lost, energy cost considerably higher. Let's just take, for example, the fan size that you would get on a normal rack of servers in a traditional data center. These fans are smaller fans. In an open compute data center, you're running larger fans. They kind of do what's more known as, say, the fan cube law, which is if I half the speed of my fan, it decreases the amount of energy it takes by 7/8. So what they've done is they've put larger fans in, cut the speed, and increase the efficiency. So I'd say energy loss is probably the biggest piece of a poorly designed data center that you can imagine. And then also, of course, you have your application issues. You have more service issues. If you're running a heterogeneous environment with a lot of different ODM or OEM parts, you have higher maintenance costs, you have higher replacement costs. So there's everything from the CapEx to the operational that can be affected with a poorly designed data center.
Mm-hmm. So I want to get into talking about some of the hardware and the supply chain and the motivation for the Open Compute project itself, because I don't think we've really gotten there quite yet. I think it's intuitive for people listening that, okay, open sourcing a data center design is great. That sounds really cool. But it wasn't until I really kind of looked into this, I understood why this was useful, why this was so important. So let's start to get there. Give an overview for some of the hardware components that are present in a data center. Like, what kinds of hardware are we looking at, and who is providing this hardware? Where is it coming from?
Okay. Well, I think let me take one step back and let me frame what the Open Compute Foundation, how it's organized and how it's run, and then you'll see both how the supply chain and then how end customers plug into this community. So, as I mentioned, after Facebook open sourced this, they turned it into a technical nonprofit foundation. It has 7 board members. So the 7 board members: Facebook, Microsoft, Rackspace, Intel, Goldman Sachs, and we have 2 individuals on that board. So it's a very lean board. So whereas you have OpenStack, which has several board members, we've tried to keep this very customer-centric. So you'll notice those names. There's really only one vendor on that name, which is Intel. It's very customer-centric. It's a very lean board. And these guys are all volunteers, so it's not a pay-to-play model. I'm not paying $1 million for a board seat. So from the board, we have 9 working projects, Jeff. So we have compliance and interoperability, so the C&I group. We have the data center project. We have a hardware management group. We have an HPC group, networking, rack and power, server, storage, and network telco. So each one of these 9 projects is run by a volunteer For example, in the data center project right now, you have a person from Google and a person from Schneider Electric running that project. And what those project leads do is they manage their individual communities. So they will hold monthly meetings. They will help set the charter for that project about what does that group want to work on. And they will also handle inbound contributions. And I'll get into what a contribution looks like here in a minute. So those guys run 2-year terms and they're voted on by the community. And then from that, the final vote about whether or not a contribution or a specification comes into the project is run by the incubation committee. So that's essentially how the project is run. It is a typical open source structure. There are a couple things that we actually take ownership of. One is the specification. So if I'm writing a spec for a motherboard or a network card or a rack design or even a data center, I can write that specification. I would work with that project lead, provide my engineering evidence, have a presentation or a review, feedback from the community, and then it's ultimately voted yes or no into the community. So if I'm a supplier, one of the things that I'm going to do is saying, okay, what areas of my product portfolio would I be open to writing a specification for? So the good thing about writing a spec is that I'm kind of the one setting the trend. I'm the one that's saying, this is my spec, and then you'll have other suppliers that adhere to that spec. And of course, we have all the typical open source licensing in place that not only opens it up, but also protects IP in certain circumstances. So the other piece that we take specifications, and then we'll also take design files. So let me go back to the example of a rack. If I'm Facebook, I may say, this is the type of rack design that I need. So they will spec out a rack design. They will then turn that over, and they may have 4 or 5 manufacturers. Again, one specification, multiple sourcing suppliers. Those suppliers will then show the community or show Open Compute project leads that, yes, my rack design meets the specification that Facebook submitted, and here are my design files. The design files are everything from Gerbers to mechanicals, all of the real hardcore stuff that you would need. In some cases, they say, here's my proof that it meets the spec, but I can't really give away my design files due to some IP reasons, and we have a path for that as well. So between those two, you're going to see the terms OCP accepted, OCP inspired. The accepted piece means that, yes, I've proven it, and here's my design files. The OCP inspired means that I've done this, but I'm not giving away my design files. So those are the two things that we take into the foundation: specifications, design files, and then we'll recognize products that adhere to that via the accepted and inspired products branding. Now, if I'm going through the piece about how a company plugs into this, one is I'm an end customer and I adopt this. So if you could look at how do I take advantage of exactly what the hyperscalers are doing, what can I see what they're doing, you can actually see the entire specs of the Facebook servers, their motherboards, even their new AI servers are being open sourced as well. So this gives a chance for larger enterprises to adopt or at least see what the hyperscale tech guys are doing and adopt components of that in their own data center.
At Software Engineering Daily, we need to keep our metrics reliable. If a botnet started listening to all of our episodes and we had nothing to stop it, our statistics would be corrupted. We would have no way to know whether a listen came from a bot or from a real user. That's why we use Incapsula to stop attackers and improve performance. When a listener makes a request to play an episode of Software Engineering Daily, Incapsula checks that request before it reaches our servers and filters bot traffic, preventing it from ever reaching us. Botnets and DDoS attacks are not just a threat to podcasts. They can impact your application too. Incapsula can protect your API servers and your microservices from responding to unwanted requests. To try Incapsula for yourself, go to incapsula.com/sedaily and get a month of Incapsula for free. Incapsula's API gives you control over the security and performance of your application, whether you have a complex microservices architecture or a WordPress site like Software Engineering Daily. Incapsula has a global network of over 30 data centers that optimize routing and cache your content. The same network of data centers that is filtering your content for attackers is operating as a CDN and speeding up your application. To try Incapsula today, go to incapsula.com/sedaily and check it out. Thanks again, Incapsula. There are proprietary components throughout a traditional data center. Can you give us, so software, in the software world, we've gotten to a point where most of your software, you can just have an open source library do the trick. I mean, you can certainly choose a cloud service provider to give you a managed service, and there are advantages to that. I can choose any number of hosted pub sub providers, or I can just run my own Kafka. I've got the option. In the data center world, at least 10 years ago, that was not true. You just had all proprietary components, or mostly proprietary components, I think, or a large percentage of them. What's going on with that proprietary stuff? Like how onerous is the vendor relationship that the data center designer and builder establishes with whoever is providing that proprietary platform that the data center builder is working with?
It varies a lot on the culture of the company that I work with. If I'm speaking with certain customers, they like that managed service approach. They have no problem with the proprietary world. In fact, there are some public entities in Asia where they have a managed service provider that has the bulk of the contract, and they get fined if things go down. So they are into this 24/7, whatever it takes. I don't mind paying the extra upcharge for this proprietary gear. In a different cultured organization, somebody that's a bit more open, they find it tedious to have multiple relationships across this and trying to find the interoperability. In the open compute world, Jeff, you have this idea, again, one specification, I have multiple suppliers. So if I like this particular spec, then I have multiple ODMs that I can actually go get this from. In the OEM world, even if it's one spec, HP's version might be different than Dell's version, which might be different than IBM's. And then again, we go back to the spare parts and having different supply chains. The open compute world, while it is open, Jeff, it means that some folks used to have a single contract that they would have with this managed service provider. Then that managed service provider goes out and sources all these different components, whether it be proprietary or open source. In the open compute world, it gives you the flexibility. We have partners that will do this one-stop shop, and they'll be the main service provider for everybody. And then we have other companies that are much more, okay, now I can break up and I have the freedom to go develop my own supply chain relationships. Let's say maybe they have a better relationship with hard drives, so they go out and develop their own relationship there, even on the open networking side. If you look at the market share, what IDC just came out with a couple days ago, around the Q1, the ODMs, so the guys you've never heard of, the Quanta, WeWin of the world, the guys that make all of the server components, the add-on, which makes all the networking components for the traditional proprietary guys, have gained 9 percentage points over the traditional OEMs year over year through quarter one, and their business is growing up over 40% compared to the other guys, which their business is quite flat or growing single digits. So it's pretty impressive what the open movement is doing across not only what customers are actually trying to consume, but also for these businesses that you may never even heard of, with the amount of turnover that they're ready to do.
When a new piece of technology gets invented in, let's say, an electrical engineering lab somewhere, a university, and then it gets commercialized, and then it makes its way to the data center operator, or maybe that's not the path. I don't know. Take me through like the process of invention of a new data center component, and like, does that process change after the Open Compute project? Like, do you think, how is the business model changing, the commercialization process changing as the components of a data center are getting open source? Because I mean, so like in software, we saw some really interesting changes to the way that software gets created and distributed after the kind of open source revolution, after we saw how good Linux could be. So what's changing in the supply chain ecosystem after the Open Compute project?
I would say there's three different areas that I see changing in the last 6 to 12 months. One is the way that things come to market. As you'd ask, okay, so what actually happens in this? In the traditional world, you usually have the OEM with their engineering resources developing a product that may be customer specific that then they roll out to the masses, or it may just be a more standardized product that they see fits a multitude of segments or industries. A couple of examples in the Open Compute world is where you have Google teaming up with Rackspace and IBM to jointly work on an Open Power project and an Open Power SKU and Open Power 9. So this is a pretty interesting example of engineering resources from three different types of companies: a vendor, a service provider, and then a hyperscale, pooling all their researching and engineering teams together to come up with a brand new product. And from that, if they open source it, then other folks can take advantage of all of that engineering mental horsepower that took place. Another example is that you have Facebook, which co-designs, Microsoft, which co-designs a lot with certain ODMs. When you're looking at particular specification, it may be co-authored between, say, a vendor and one of the hyperscales. So I'd say the biggest difference in the traditional way is that in the past, you wouldn't have access to what Microsoft or Rackspace or Facebook is actually designing. In this case, not only do they design it, but then they share what they're doing with the rest of the world. So that's one piece, is on the actual product itself. The second component of what's changing is in the OEM world. In the last year to 24 months, you've seen HP and you've seen Dell both come out with open lines of products. So the HPE Cloud line is a product line that they developed 24 months ago that is actually OCP inspired, which means that they've met certain tenets of the Open Compute project, and I'll get into those in a second. But you'll see Dell and HPE being pulled this direction as well. This could be either from, again, back to the new market entry that they wanted to see, or maybe the larger guys are pushing this direction. And then the third piece is on the facility side. Jeff, I've encountered a lot of managed colo facilities in Europe and Asia that are looking for ways to differentiate themselves. So in the past, the motto is, I sell ping, power, and pipe, and I just sell space. What some of these new European colo facilities are doing is they're trying to figure out a way to differentiate themselves in the market, whether it be in the Nordics or, say, in Netherlands, where they can actually have an entire floor of their data center that is OCP compliant. And from that, let's say, for example, they don't need the chiller units that I'd mentioned in the past, so they can actually cut that out of their cost, or you provide this as a menu option to your inbound customers saying, would you like Open Compute gear? Would you like standard gear? Here are the benefits, here are the efficiency savings. And in Japan, where power is extremely expensive right now, these types of models are becoming more appealing, so on the facility side. Back to the tenants piece, there are really four key things that we look at for Open Compute on the tenant side. We look for openness, impact, toolness, and it has to adhere to open software. So these are the four real key things that we look for to make sure that something fits well within the community.
I'd like to continue to motivate why this is an important project. So if I were to purchase all of my hardware off the shelf, there's probably going to be some different components across that hardware that might waste power. They might be inefficient for other reasons. It's kind of like, when you have proprietary software, you oftentimes don't know really how it works, so you get some waste. This is the classic open source model. When you get more eyes across a technology, you get fewer mistakes because people are noticing the mistakes. What are some of the other areas of waste that are being eliminated by the Open Compute project?
I've touched a lot on the energy side, so I think that's pretty evident. There's a great study out there that SK Telecom did out of Korea where they tested 3 different types of Open Compute configurations, including Hadoop and OpenStack, versus their legacy gear, and found the efficiency ratings pretty impressive. The second piece is on the cutting out a bit of bulk on the embodied energy. So in a Facebook data center, or it's actually in different types of Open Compute, if you pick up the actual server at Facebook, it's actually lighter than what you would get from other companies. So the embodied energy, the actual e-waste, is less in an Open Compute world. Another piece is around serviceability. So as I'd mentioned, one of the tenets being toolless designs. So it's imperative that we have an obsession with simplicity within Open Compute. You have to be able to repair and replace an Open Compute piece of technology without using a tool. They just have contact points. So when Microsoft is rolling out Open Compute, they're saving almost 50% in deployment and serviceability times. Pretty impressive. Now, as you take a look at some of the folks in certain parts of the world, reducing headcount may not be the most attractive thing for a manager in that case. They might appreciate what they have and not want to lose that to other areas. But what we're seeing in some of the more forward-thinking companies is, yes, I can take these guys out of the data center, I can reskill them or move them over to the other areas of the business where I need it. So energy efficiency, serviceability, and the last piece, which is supply chain. We're hoping long-term that the supply chain becomes smoother and as effective as an OEM supply chain, having the ability to cut out a lot of the things that you don't need in a server, in a storage unit, in a rack, in a data center, hopefully drives down that overall cost. So again, energy, CapEx, and headcount.
So I was watching some videos of the Facebook servers and how they're built, and they're designed so that the components are very easily swapped. Like, the last time I opened up my desktop computer, it's a pretty old desktop computer, but the last time I opened it up, it was not easy to open. There were tools that I needed to swap out stuff, and it was like, I think I cut myself a couple times. And Facebook servers look more like Lego blocks. They're pretty easy to swap out components. Do these servers ever burn out completely, or do you just continually replace components?
No, I don't know exactly the failure rate, but sure. But in the world of Open Compute, you're building redundancy at the software and the application layers. So it doesn't really matter if I get around to replacing this server now or next week or once a month, whenever I have my periodic replacement schedule set up. So I know that we've talked a lot about Facebook and Microsoft and some of the other larger companies, but since the inception of Open Compute, it's now broadened out significantly. So it's not just the hyperscale SKUs or specs and products that have been contributed. We now actually have Project Olympus, which is Microsoft's new offering, and then we also have a carrier-grade 19-inch rack offering, which is really geared for telcos and more traditional infrastructures. So you're seeing a broadening of the Open Compute community where we realize that in some cases what Facebook does is going to make sense and I can do it, because keep in mind Facebook has a large team that they can manage all of the management piece of that, the software piece, and they have a significant team compared to, say, an enterprise based in Korea or based in Singapore, where their team might be much smaller. We do have products that and specs and certifications that adhere more toward traditional infrastructures, that I'm not building a brand new data center. I still have to deal with my colo. I still am a tenant in this colo and driving efficiencies that way.
So when there are these different companies that are talking in the Open Compute project, do they have unique requirements? Like, does Facebook have unique requirements given its throughput compared to Goldman Sachs? Because I just look at Facebook and Goldman Sachs, and I'm like, at the level of the data center, it seems like both of them would just have like a lot of writes, a lot of reads. It's kind of like all the same. Am I wrong about that?
I think you're right as on some of the specifics. However, their infrastructure setup is considerably different, where Facebook, if they want a new data center, they go out and build it. Goldman doesn't necessarily do that. They work in a lot of colo facilities and a lot more traditional infrastructures. Their designs are not the same as what Facebook is using. So back to my original point about, we have multiple designs depending on what kind of industry or what kind of workload that you may need. In some cases, the Facebook design is good. In other cases, the Radisys design, the company based out of Portland that's doing all the work for Verizon with their carrier grade 19, is more of a fit. It really does depend significantly based on what kind of industry and what kind of workload. But one of the interesting things, Jeff, is I've talked to probably 4 or 5 companies in the last 2 months, all different industries, but they're all trying to do the exact same thing, and that is they want to do Hadoop on top of Open Compute. So it didn't matter if I was a bank or a gaming company or a healthcare company, everybody seems to be rolling out Hadoop, and they want new open infrastructure underneath that.
When a data center design is open sourced, what exactly is being open sourced? What's the file format or the presentation format?
Well, when you say data center design being opened up, I want to be clear that it could just be a network card, it could be a switch, it could be a server, it could be the actual overall building design. In that case, it could just be, again, a written specification. I could take this and download the spec, it'll have some drawings, then I could take that to a manufacturer and say, can you please make me something similar to this? In the case where I've disclosed the design files, I can get down the mechanicals and the Gerber files and simply take it and go manufacture as well. Those are really the 2 key formats that we see.
In 2011, as we've said, Facebook shared its designs with Intel, Rackspace, Goldman Sachs, and the public. Could you tell the story of how that went down? Did it make sense to all the people that Facebook was talking to, or was there some skepticism around the project?
Frank Frykowski, who started the Open Compute project as director of infrastructure at Facebook at the time, I think that between his idea of what, I think he was struggling with the lock-in that you face and the flexibility or the inflexibility of the OEMs to be able to do exactly what they need to do. And I think that they were, at that time, extremely progressive. I'm sure that they received a great deal of pushback. I don't know the specific story around it, but it certainly didn't take long before the community started to move this direction. Goldman Sachs is probably the best example of somebody that started in the organization. First of all, they joined as a board member. The first year, they spent a lot of time just talking to Facebook about what are you doing, how are you doing it. The second year, they started to test it. The third year, they started to deploy it, and now they're running 50 to 75% of all of their new stuff is Open Compute. So it takes a bit of time here. This is not something where I stop. All of a sudden, I start buying some Open Compute gear and I get it up and running. Talent pool, Jeff, is something that we're lacking as well. Much the same way that OpenStack had talent issues when it first started, finding out people that knew OpenStack and was able to actually work on it. We're finding the same thing in Open Compute. It's not a typical server. It's not a standard way of deploying hardware. So it does take some learning in that piece. But we do see a great deal of software ISVs now starting to move this direction as well. So we see Of course, Canonical and Red Hat all build an OpenStack, all building reference architectures to support Open Compute Gear, which is the next layer. Because in my opinion, I can share a server design, a storage design, a network design with a company, but inevitably the question is what software runs on it. And that's, I'd say, the biggest push that we have over the next 12 to 24 months is getting the software pieces baked on top of Open Compute. They're out there right now. Some of them are published, but we need a much richer, deeper knowledge base on that.
Look for a job more efficiently with Indeed Prime. Indeed Prime flips the job search model and lets you find a job more efficiently even while you're busy with other engineering work or coding your side project. You simply upload your resume, and in one click, you get immediate exposure to companies like Facebook, Uber, and Dropbox. The employers that are interested will reach out to you within 1 week with salary, position, and equity up front. Don't let applying for jobs become a full-time job itself. With Indeed Prime, the jobs come to you. The average software developer gets 5 employer contacts and an average salary offer of $125,000 through Indeed Prime. It's 100% free for candidates. There are no strings attached. Sign up now at Indeed.com/SEDaily. Thank you to Indeed Prime for being a repeat sponsor of Software Engineering Daily. And if you want to support the show while looking for a new job, go to Indeed.com/SEDaily. Frank, who you mentioned, I saw a presentation where he was describing the relationship between like new technologies, and this was kind of the question I was trying to ask earlier. I don't know how to ask it properly, but Frank was basically describing the pre-Open Compute project relationship that providers, like supply chain providers, people who are providing different pieces of the hardware in a data center to data center operators, the customers, it was bottlenecked by something I don't quite understand. Basically, bottlenecked by the proprietary nature of these technologies. And post Open Compute project, the idea is that the relationship is more direct and transparent, and I guess more efficient. I don't know if you can do his explanation justice, but can you explain? And he described it as going from a blocking relationship to a non-blocking relationship. Do you know what he was talking about, or do you recall this sort of narrative?
Yeah, I've heard Frank speak many times on the subject in the past. There are aspects of what he was saying that I've alluded to, I guess, when I was talking a bit about the supply chain. In the past, you would get this closed server with this fancy painting and bevels. I mean, this is essentially what you got. If I'm Facebook and I need a specific web server developed, or I need this AI server, in many cases, there'd be proprietary pieces where the OEM or the ODM would want to keep that private to themselves. And I think that with this open technology, you've just got a much more collaborative spirit. And I think that you realize that it's very difficult to copy hardware. A lot of people get nervous about, say, giving up design files or saying, oh, if I share this, somebody's going to copy it. In reality, by the time it hits the market, if you took those designs, say, I'm going to go copy it, and I'm going to use everything, it could be close to a year. And by then, you're already midway through another rev cycle. So we don't see people copying hardware designs the way that a lot of companies might fear on the IP side. Of course, there's some inherent IP that companies need to protect, but overall, the openness always wins, as Frank says.
Mm-hmm. Okay, let's take a look at some of the projects within the Open Compute project. Let's take networking as an example, or you could take telco, the telco infrastructure project. Let's talk about the telco, because for some reason I find telcos interesting, and when I think of like giant companies that I have frustration with that I would love to see disrupted by open source technology, even though I don't know what the nature of that open source technology would be, I think of telcos. So explain what the telco infrastructure project is. Like, I guess give an explanation for how it operates.
Okay, so the telco project itself is within the Open Compute. It's a sub-project within the Open Compute project. And what they're working on, they've worked on a few things around the types of designs and open ingredients that they need as telcos. This entails everyone from AT&T, Verizon, SK, all working on, as they move toward the next generation of hardware for rolling out 5G, and more importantly, where Open Compute is has the biggest impact is in the Cord project, the central office re-architected as a data center. This is where a lot of organizations are looking at Open Compute to deliver edge applications across their infrastructure. So if I'm AT&T or Verizon, I may have several thousand branch offices or central offices as they're called. These central offices could run highly efficient open compute gear at a fraction of the cost using open networking. It really is pretty impressive what open compute can do to drive the next generation of telcos. In fact, the central office re-architected as a data center, the Cord project, part of their RFP requirements are around open compute. And you'll see, even if you do a search of Verizon standing up 600 nodes of open compute gear, you'll find out a little bit more about what they're doing. It's pretty impressive. And as I mentioned, SK being a pretty aggressive adopter here in Asia. And we're seeing some more things happening in Europe as well with some serious telcos. And then AT&T just made a recent contribution as well. So we're excited about what's happening there.
To give people an idea of how impactful this project is, there are entire companies that are being started as a result of the Open Compute project. Can you explain what those companies are and the changes in the data center world that they represent?
Sure. I think if I could break this down into maybe two categories. One is a division of a large ODM. So ODMs, the guys that you may have heard about in the past, maybe Foxconn. So there are a couple others that are quite significant. You have the Inspurs of the world, Quanta, Windstrom. These are all very, very large ODMs. In fact, Quanta, I think the stat came out that they make one of every 7 servers in a data center. So extremely large organizations. So as they started to go direct, Jeff, they started to develop a new business unit and brand themselves as a direct sales unit. So now you have QCT, which is Quanta's direct sales arm. You have WeWin, which is Windstrom's direct sales arm. And you'll see this more and more as the larger ODMs try to get into and go to direct markets. The other piece that's happening is around smaller SIs. So I've got 2 or 3 SIs in Europe alone in the last year that have started up entire business units just based on open compute. Where I do see the gap, Jeff, is the folks that I'd say, remember a few years ago where you had people that would go in and say, okay, here's your list of applications, I'll help you with the journey to the cloud. And they would take those applications and move them to the cloud. The gap right now in open compute is taking that journey and sitting down and saying, okay, here's your infrastructure. I'll help you with the journey to OCP. So the consulting arm of open compute, I think there's a gap there. We have some organizations that are pretty decent at filling that now, but I anticipate in the next year or two, you'll see specific consulting-only organizations going out, driving themselves as, I'll help you move your infrastructure. And then they'll subcontract out and have relationships with all of the other OCP members.
Mm-hmm. What are the long-term implications of the Open Compute project?
In what regard?
In the longest term you can imagine.
Wow, in the longest term I can imagine is that everybody would be able to use open design hardware, that it just gets completely commoditized and software is running everything on top of it, and we don't have any proprietary components within the data center, and data centers are even automated to where there's no one even needed inside the data center. It's that automated. Why doesn't
that happen? Why isn't that happening today? Why aren't data centers automated yet?
I believe there are a few folks that are testing it. I
Oh,
still
okay.
think I still think that there's a bit of a need for human interaction there. Probably because some of the proprietary gear is as well. Not everybody runs straight homogeneous environments, as I'm sure you're aware of. People have still
Yes.
very large VMware estates, and they have plenty of pets out there versus cattle.
How did the different members of the OCP vary? Do they all have like similar aims? Like, does Microsoft kind of have the same desires for the OCP as Facebook, for example, or are there like differences of opinion? And how do those kinds of things get resolved?
Certainly, everyone has different objectives and goals when they join Open Compute. It's one of the first questions I ask them. Let's take Alibaba as an example. They just joined a couple months ago. And I said, look, you guys have your own Open Compute type of project happening in China. It's the ODCC. It's where Alibaba, Baidu, Tencent, China Unicom, China Mobile, and the government have all kind of come together and done something similar to Open Compute where they share designs among those guys. But Alibaba joined Open Compute just in the last 60 days because they said, look, we're building more and more data centers outside of China, and the engineering collaboration and the engineering horsepower that we would get working with a broader community now, I mean, we have over 4,000 engineers in our community, is what we need to drive our data center thought process outside of China. So we're excited to have them. So that's one example of their goals. Certainly Google has different goals than, say, IBM or even Fidelity. The way that manifests itself is through the projects. So the projects will sit down and the entire community will define that charter. Back to your telco example, when the telco project started a year ago, they sat down and said, okay, what is the charter that we want to work on? And that's AT&T, DT, Verizon, Nokia, Ericsson, all coming together saying this is what we want out of this project. So that's how the differences get worked out. And it's usually, the majority wins. And in the case of rack architectures, we settled on 3 different types of rack architectures driving forward, and we expect to do that across the other projects as well.
When I think of open source software, I think of a lot of rogue developers contributing to a code base. And some of those rogue developers, maybe you have, like 5 people from Google who are all working together on Linux. So you get these factions as well as rogue programmers across an open source software project. Open source hardware seems a little bit different because the agents that you're talking about are giant companies. How does that change the kind of like the governance or the diplomacy that occurs across this open source organization?
It's a very methodical, well thought out process for a contribution. So we have several individual members of, say, an organization that the organization itself is not an active member within Open Compute. You may have I know of a couple members of a large bank. They're members of Open Compute, but the bank itself is not members of Open Compute. The way, as you work through that specification approval process, as I'm working on a particular project, as I have a spec contribution design idea, if I'm actually making the spec or even if I have a need, I can voice that to the project. The project meets every 6 to 8 weeks talking about upcoming contributions. They'll vet these extremely thoroughly and then moving, of course, to the incubation committee. So the incubation committee is made up of 11 people, 1 from each project. The 9 projects, 1 person from each project, a chairman and a vice chairman. So think of it as kind of the Congress and the Senate. And that's how things ensure that there's no fragmentation, that things are aligned with the charter, and that we have a uniform direction that each one of those projects can adhere to.
Well, I feel like we covered most of this project, and not most of it, but at a high level, I think people at this point have an idea of what the Open Compute project is, why it's important, why this is going to be really important in the future. I guess let's talk a little bit about the future. Cloud computing, it's difficult to overstate how much of an impact cloud computing is having on the world. Just the fact that I can access a server for pennies on the dollar and do important stuff is, I mean, so tremendous. It can't be understated. And when I look at this Open Compute Project thing, like in addition to all the trends that continue to happen at the hardware level, Moore's law type of stuff, I'm like, wow, it seems like the cost of compute is really going to go to something like zero for like early projects, right? Like that seems where it's going. That sounds accurate to you?
Yeah, it does. It absolutely does. Especially in the open networking case, Jeff. I mean, the growth that we're seeing in open networking through the companies, say EdgeCore, Acton, the guys that are making a lot.
What do you mean? Sorry, what do you mean open networking?
I'm talking about white box switching, switches that sit at the top of the rack.
Yeah.
Yep. So you're going to have instead of a proprietary switch, say from Cisco, you've got open networking switches that then you run like a Cumulus or a big switch or a PICA-8 on top of that, and that's probably the single biggest growth area that we have within open compute. Right now, I would say it's in the high 40% growth year over year of what these open networking guys are experiencing. And I'm talking about not massive deployments, as small as, say, 10 to 15 to 20 switches in the middle of Southeast Asia. These guys are now starting to use open software on top of open networking because they're tired of they want to do more things that are open, and they're a little bit tired of their existing relationships in that model. So I think that your idea about, yes, it's driving efficiencies into the market and the cost lower is completely accurate. I think that Gartner had a stat up that said, by 2020, 30% of your strategic relationships are going to shift. So you're going to go from the Cisco to the Junipers, from VMware and Aristas, all the way over to Acton, QCT, Chef, OCP, Docker, OpenStack, AWS, and I would assume that's maybe even more than that. I mean, 30% seems low to me. It seems probably like 30% is now. So by 2020, I would assume it's going to even be higher than that.
That's great. So as we're wrapping up, are there any newer things in OCP that you're excited about? Any special sneak previews you can give us, or just stuff that we didn't cover?
Yeah, sure. I like a lot of the new stuff that's coming out from the telco. I encourage anybody that's interested, if you go to opencompute.org and participate, you can join any of the mailing lists there to see what's happening. And then, of course, we just launched the marketplace at opencompute.org, which gives you a chance to filter on any of the available products and all of the contributions. So if you want to see what somebody has actually contributed, you can actually download the specs. And so that's brand new. We're very excited about that. And of course, we have our summit in March every year in the Bay Area, where we have over close to 3,000 folks in the open compute world. Just more good things to come from OCP. So I appreciate the offer to help share a bit of this to the audience, Jeff.
Absolutely. Well, Steve, thanks for coming on the show. It's been great talking to you. Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!